All right, so the next topic we need to talk about is in circuits is capacitance and capacitance. What a capacitance is a plate, and then a distance, a gap of some sort. Sometimes that gap is filled with material. We used to have a professor that would say some sort of dielectric goo. That would be in between those, and then another plate. So it's two plates, the gap in between. And sometimes that gap is filled, actually more times than not, that gap is filled. So that when a current is applied to this system, the electrons just simply don't jump across. That's the idea of a capacitor. How does it work and what does it do for us? It is another story. How it works is if I apply a voltage to a capacitor, well, I should flip those. Electrons start to move. Obviously, electrons move in the opposite direction of the current. The electrons start to move. Now, these capacitors are made out of conductive material, and conductors distribute charge evenly across their surfaces. So if I release one electron, that electron ends up on that surface. Okay. Now, if I release another electron, that another electron moves that electron, so they start to evenly distribute across that surface. More electrons dump into the system over and over and over and over, all of them evenly distributing themselves across that plate, that metal plate, typically copper, but that's where those electrons are getting distributed. Well, what happens when I build up charge like this is that I generate an electric field. Okay? That electric field is the potential for a force. If I introduce a charge into that electric field, that charge will experience a force and will start to move. Well, the electric field that's being generated, because these are electrons, are in this direction. Yes. So we get these electrons, or this electric field building up inside of that, inside between those two plates. But the really cool thing is that these electrons, this electric field, is moving electrons on this plate because that's evenly distributed too, but it's neutrally charged. There's an equal number of electrons in there of protons, but this electric field is pushing, it's pulling the protons this way and pushing the electrons that way. Well, the protons have nowhere to go, and they're protons too, so they don't like to go, so they stay there. But the electrons leave. Okay? They leave the circuit, and then they go back around. Okay? So all the while it's building up charge on this side, forcing negative charge to leave on this side, come back around, and eventually, after a given amount of time, the electrons on this plate reach a maximum. Okay? No more charges can go on that plate. No more charges move about. I've reached my maximum number of charges on that plate, and I've liberated the maximum number of electrons on the second plate, and we're done. Okay? What does that do? Well, besides create that electric field, I've now created a battery. Okay? I've given myself a place in which I can store electricity. Okay? I'm storing electrons in between these two plates. If I were to take those two plates and then connect them to a light bulb or to a person, the electrons are now wanting to dump away. They've achieved an equilibrium. There's pressure that's stabilized, but once I remove it from that voltage, I don't have a circuit, so nothing can move. And then I take those wires, I drop it on that light bulb, all of a sudden, boom, electrons start to pour out. And as a matter of fact, those electrons will probably pour out faster through this whatever, this device, this light bulb, this person, whatever, than it did to take a charge. So it may take a long time to charge this up, but more than likely, the way it depends on how you set up the circuit, those electrons will dump out really quick, through this device, whatever it may be, a defibrillator, for example. It's a nice way of dumping a lot of charge very quickly. A capacitor basically controls the rate in which we can dump charges. Okay? But that's what it does for us. It stores electrons, which is storing energy. It's storing electrical current in a sense. I mean, if you ever take a computer apart or something along those lines that have been plugged in, the first thing you need to do is discharge those discharge those capacitors. You've stored them. So either you can do it the smart way and use a device or use something that's grounded and ground the circuit, or you can use your finger and it'll ground through you. Okay? But that's what it's designed to do. Designed to store charge. That's what a capacitor does. Okay? Now I'm going to talk about capacitance.